Hello friends, so today's question is happy number. Okay, so what they're asking from us is we have to write an algorithm to determine if a number n is happy. Okay, so what happy number is or what we can say is a happy number. So they have given happy number can be determined by the following process. So we are starting with any positive integer and replacing the number by the sum of square of its digits. Okay, so like if we are having this, if we are having 19. Okay, so what basically we are doing, we are making a square of each digit. Okay, plus 9 square, so it becomes 82. Okay, so when we have a square the digits of this number and added them, so it becomes 82. Okay, so repeat, we have to repeat this process, now we will again square its digit 82, 8 square plus 2 square. Okay, so we have to repeat this process until it becomes 1. Okay, or it endlessly goes into a loop. Okay, we will look for an example where it will go endlessly in a loop. Okay, so there are two ways, doing this process we can either get one. Okay, or we will fall into a endlessly loop, infinite loop. Okay, so if we are getting a one, we have to determine, we can say that yes, this is a happy number. Okay, or if we are not getting a one at the end, or we are getting into an infinite loop, then we can say that it is not a happy number, so we have to return false. Okay, so what they are saying, like we are given a integer value. Okay, we have to sum the square of each digit of this number. Okay, like in next stage become 82, and we have to repeat this process until either it returns a 1 or it ends up into a infinite loop. Okay, if it's end up in as 1 result 1, then we can say that yes, this is a happy number, so we have to return true. Or it end in an infinite loop, or it does not result into 1, then we can say it is not a happy number and we have to return false. Okay, so basically this is the question they are asking. So like if we look into first example, let me just, so like if we take the first example 19. Okay, so we have first, okay, let's do it here 19. Okay, so first we have to make a square of 1 plus 9 square, 9 is 80, result into 82. Okay, then we do the square of each digit of this number. It is 64 and 2 to the 4, so it becomes 68. Okay, then we again do, so 6 is a 36 and it is a 64, that in become 100. Okay, now we square them and add them, it become 1. Okay, so like after repeating the process again and again, at the end what we are getting, we are getting 1 as our end result. So we can say that this, yes, this 19 is a happy number and we can return true. Now in other example, let's say, okay, let's have 2. Okay, so if we square this, it becomes 4. Okay, then 2 become 4, and then it again become 4, 16. Okay, then 6 is 36, it become 37. Okay, Simpsons are 49, and it becomes 50. Simpsons are 49, and 3 are 9, it become 58. Okay, then again we square, so it is a 64 plus 25, then it become 89. Okay, then again we square. Okay, so 81 plus 64, it become 145. Okay, then again we multiply 25 plus 16 plus 1, it becomes 42. Okay, 42. Now again it becomes 16 plus 4, it becomes 20. Okay, so it becomes 20. Now again we multiply, so it becomes 4. Okay, so now we know that this 4 we have encountered. Okay, so we know that yes, previously also we have encountered the 4. Okay, so if we continue doing this process, we will end up into a loop, because 4 again we will process for 4, then 16, 37, 58, 89. Again this will, again we will encounter a 4, then again we will start this process, so this process will go on repeating itself. So here we can say that it is not a happy number. Okay, so understood. Like in one case, when we are ending up at 1, we can say yes, it is a happy number, we have to return 2. But in this case, like we can see, we have started with 2, we encountered 4, but after certain operations we again encounter 4. Okay, and we know that if we have started with 4 and we are ending up with 4, then again we have to repeat the same process and we will end up with the 4. Okay, so this will go on infinite. Okay, so we can say this is the infinite loop, and we cannot end up into 1. Okay, so we can say this is not a happy number, so we will return false. Okay, so we have understood the question pretty well. Okay, now to its solution, like basically what we are determining, like okay, in this case only we see now we have to like whatever the operation, like we have encountered 2, we have encountered 4, in this case 4, like again if we have encountered some other value instead of 4, then we have to make check of that number, that whether we have whether we have encountered this value previously or not. If we have encountered it previously, then we can say yes, then again we will repeat the same process with the same number, and we will end up with the same number. Okay, like here 4, we have started with the 4, we end up with the 4, and then again we will, if we start with 4, then we will again end up with 4. Okay, so like we have to make a check, we have to make check like whether this element has previously occurred or not. If it has not occurred, then we can continue with our operations, or if we have if we have already seen that number, then we can say yes, it has previously occurred and this is not a happy number, we will go into infinite loop. Okay, so for that key use case, what we will use to track frequency of any number, or to track whether it has occurred or not, we can use a map here. Okay, like basic map we can use. Okay, so what we will do, every time we encounter any number, we will put it into a map. Okay, like let's say example of 19 only. Okay, so in first case like 80, 82. So okay, so we have encountered 82. Okay, so we will check, okay, 82, its frequency we will make 1. Okay, then again it is a 64, then 68 it becomes. Okay, so it's 68, frequency will become 1. Okay, now 68 is a 64, then 100 it will be, so 100 frequency will become 1. Okay, then it becomes 1, so we have encountered 1. Okay, so we will return it as a true happy number. But in case of 4, okay, like for 4 is a 16, and this loop will go on, and again we will encounter a 4. So already we have 4 frequency as 1, and again we have encountered a 4. So we will check whether we have encountered a 4. This is for the this example. Okay, for this example we have another separate map. Okay, so we have started with 4, like 2, then from 2 we have gone into 4. So 4 we have started, so we have already 4 is marked as 1, and again we have encountered a 4. We will check in this map, okay, whether this element is already present in the map. If it is already present, then we will return false, otherwise we will return we will continue with our process, and if it in the end we get 1, we will return true. Otherwise, if we encounter any other element which is already present in the map, we will return false. Okay, so basically we will use map here. So now let's quickly jump into the solution and code this. So let's say uh, let me go map of int comma int, let's say count. Okay, now while, okay, so every time, like where we have to stop, we will like initially we are having n as 19. Okay, but every time we will change its value. Okay, we will, every time n's value will be a new one, like in first iteration it will be 19, in second iteration it will be n is equals to 82. Okay, so we will check until n is greater than, until n is greater than 1, we will loop. Okay, now what we will say, we will first of all check, okay, if count of n is equals to 1. If it is already present in the, we will return, we will stop and we will return false. Okay, else what we will do, else we will increment the count, count of n is equals to 1, we will do it as 1. Okay, now this we have done. What we have for any new number, we have first checked in our map. If it is not present, we have marked this frequency as 1. If it is already present, we have stopped the loop and we have returned false. Okay, now what we will do, now every time, like okay, now we have to perform this operation of 19, like it will be 1 square plus 9 square. Okay, so for that, so what we will do, we will again do a while loop. So if we change into a n value, we will store n value in a temporary variable. Okay, is equals to n, and then we will again make n is equals to 0, because n will be getting a new value. Okay, so while temp is not equals to, or temp we can say is greater than 0. Okay, what we have to do, first of all we have to find the mod. Okay, so mod we have done, so temp percentage of n, so we have got the digit. Now what we have to do, we have to square and add up into add up, like 19 we have to square and we have to add up, so we will do that. N plus is equals to mod multiply by mod. Okay, so this we have a square, then we will divide our temp is equals to temp divided by 10. Okay, so basically this is a operation that we perform. So if we have done this and we have like whenever the loop is over, either it will end up in infinite loop, okay, or it end up in one. Okay, so when if we have not encountered this condition, then definitely this is our happy number, so we will return true here. Okay, let's run this and check now. So yes, it is accepted. Now let's submit and just check whether it passed all the test cases or not. So it is accepted successfully. So for time complexity and space complexity, okay, so for space complexity, as we are we are not using any fixed space, so its space complexity capital O of n, space complexity, and time complexity will be capital O of log n. Okay, so thank you for watching.